Next, we need to discuss muscles. We want muscles to be pliable and relaxed until we need them to actually contract. However, most muscles also have a relative stiffness to them that is present. For instance, if I have a large muscle, I've really focused on developing hypertrophy of that muscle, then it's going to have a certain amount of resistance to it when you pull on it or try and lengthen it. Shirley Sahrmann describes these muscles as being very large springs with a certain amount of relative stiffness to them. So they need a certain amount of force to uncoil them. Other muscles might have relative flexibility, meaning that they are not nearly as hypertrophied, so they go along for a ride. If I have highly developed pecs and underdeveloped rhomboids and mid-traps, odds are my shoulders will come inwards. This demonstrates the concept of relative stiffness and relative flexibility. I'm sort of out of balance, so even though the muscles might have normal lengths, there's a tug-of-war balance that one is losing to the other. However, there are also times when our muscles are shortened and not lengthened for other reasons. Muscle guarding and also adaptive shortening. See, muscle guarding is a reflex issue. You have mechanoreceptors in the muscles themselves and in the tissues around them. And these are little sensors that are trying to detect any particular movement changes. Most are actually incredibly helpful. They're trying to make sure you don't overstretch or overwork your muscles. Muscle guarding is when a particular sensor feedback loop is constantly telling your muscle that it needs to shorten. Usually this happens in the presence of pain. Your muscle is trying to limit your motion so you don't feel pain. You don't go into a painful range. So it's like you're sort of contracting this muscle submaximally but constantly. This guarding can also happen during particular movements. It doesn't have to be on all the time. It can be occurring when you sort of get to a certain range in your motion. Then the mechanoreceptor kicks on and the muscle guards, not allowing you to go any further. This last concept is actually the theory behind your overall flexibility, the idea that we are born with a certain amount of total potential range. But then our neural system adapts and decides what is the comfortable or safe range we should be using. So when you try to touch your toes and you can't, that could be that you're tight, but it could be that your muscle spindles, the mechanoreceptors, are sensitized or cautious and need to be trained to allow you to go further. You need to show your body that it's safe to use that full range. In this theory, stretches aren't being done to increase a tissue length, but instead, they're being done to train your nervous system. There is a scenario, though, when muscles also do get short. This is adaptive shortening. This is the concept of a joint or a limb being kept in a shortened position for a long time, and eventually what happens is the muscle itself gets short. This happens because our cells are constantly being broken down and remade over time, and it's not a fast process, but it is continuous, and the body is very smart in that it conserves energy and resources. So if you have your knees bent and are sitting in a wheelchair, for instance, for months, the body might rebuild shorter sarcomeres in your hamstring. It thinks that you don't need longer muscles, so it creates shorter ones for you. It's going to use those resources somewhere else. This is a scenario where it isn't a software issue, it's a hardware issue. The actual muscle is short. You aren't having a protective program tell the muscles not to lengthen to their fullest. The muscle just can't go any further. Another concept for muscles is spasticity. We talked about muscle guarding, which is more of a local concept. You have sensors in the muscles that quickly go to the spine and back out to the muscle. It's all locally happening sort of in a process. The brain isn't really called into that situation. Spasticity is what we're now talking about is potentially a brain or upper motor neuron processing issue. This is classified more as a neurological disorder, and the motor patterns you see with spasticity will be very telling.